Welcome to Study Loop.
Our question says that a batter hits a fly ball which leaves the bat at 0.9 meters above the ground at an angle of 61 degrees with an initial velocity of 28 meters per second headed towards center field. Ignore air resistance. A, how far from home plate would the ball land if it was not caught? And B, the ball is caught by the center fielder, who starts at a distance of 105 meters from home plate, runs straight towards home plate at a constant speed, and makes the catch at ground level. What is his speed in order for him to be able to do this? So I wrote down here what we were given. V naught is 28 meters per second. Theta is 61 degrees. The height of the ball hit off the bat is 0.9 meters. That's Y naught. And for the first instance, and even in the last one, we consider it to be at ground level, and ground level is 0. So our final value, Y, is 0. So the first thing we need to do to find out how far it goes, if we know its initial velocity and its initial angle, we know V of x. So to find x, we need to know the time it travels. Okay, so the time it travels can be found by using y is equal to y naught plus v of y, the velocity in the y direction, times the time, plus 1/2 acceleration in the y direction times the time squared. Okay. Well, let's go ahead and simplify this. We know that y is 0, so this is 0 is equal to y naught plus v of y times the time minus 1/2 g, because the acceleration in the y direction is gravity in the minus y direction. So this is minus 1/2 g times the time squared. So if we want to solve for time, we can use the quadratic formula where t is going to be equal to minus v naught sine theta plus or minus the square root of v naught sine theta and that's squared. So v naught sine theta, let's make this look more like a theta. There we go. Squared minus 4 times minus 1/2 g multiplied by y naught. Okay. All divided by 2 times minus 1/2 g. Okay, so now we know all the values that we need to plug in this equation. We have y naught, it's 0.9 meters, theta is 61 degrees, v naught is 28 meters per second, gravity is 9.8 meters per second squared. So plug all those values in your calculator, and you'll find that you're going to get two values for t because of the plus or minus. One of them is 5.034 seconds. And the other one is, we'll put a comma here, minus 0.0365 seconds. Well, we can't have minus time, so we're going to ignore that. We're going to use the positive time for our t. So now we have x is equal to v of x, velocity in the x direction, times t. Okay, well, v of x is v naught times the cosine of theta times the time. Okay, well, for v naught, you plug in 28 meters per second, multiply that by cosine of 61 degrees, and then multiply that by the time, which we found to be 5.034 seconds. And you'll find that the distance is 68 meters. So that's the solution to part A. Okay, start a new page, because for part B, it says, well, the center fielder starts at a position that was 105 meters away and sprints into where this ball is going to land and catches it right before it hits the ground. And they want you to know, or they want to know how fast he's going to be traveling in order to do that. So his velocity, v, would be equal to that distance that he's going to be covering divided by the time it would take him to cover it. Okay, Well, that distance is the starting point, 105 meters away, minus 68, because that's how far the ball goes. So that the difference there is how far he needs to travel, divided by the time, which was 5.034 seconds. Okay, plug this into your calculator, and this comes out to be 7.3 meters per second. And that's how fast the outfielder would need to run to get to the ball.